This is Lesson 4-3B from the Algebra Readiness textbook. For today's lesson, you'll need your notes and a sharpened pencil. Pause the video to gather your supplies and work the study guide problems. Continue the lesson when you're ready to compare your answers to mine. Because 89 has only two factors, 89 is prime. The two factors are 1 and the number itself. The next question, what is the prime factorization of 168? Show your work. Because, let's see, there's a couple ways you could go. Let's just start by saying it's divisible by 2. Some of you maybe went with 3. And I would say 84, then 2 is prime. 84 is divisible by 4. And that's 21. 4 can be 2 times 2. 2's are prime. 21 is 3 times 7. 3 is prime, 7 is prime. So the prime factorization is 2 to the third times 3 times 7. All right, for today's lesson, we're going to work on using the prime factorization to find the greatest common factor. It is also known as the greatest common denominator. Those are used interchangeably in the math world, greatest common factor and greatest common denominator. So let's write these down, or write this definition down in our notes. The biggest factor that is the same for 2 or more numbers or expressions. The biggest factor that is the same for 2 or more numbers or expressions. Now you have two options for how to find the greatest common factor. One way is to list all of the factor pairs, or the other way is to use the prime factorization. If there are no common factors, then the greatest common factor is 1, because 1 is a factor for every single number there is. So if you can't find any, then it's 1. Find the greatest common factor for each pair of numbers or expressions. Now, I know that you've done greatest common or factor before in 6th grade, but in 7th grade, you're going to see some that include variables, as in option B over there. So I'm going to show you the best way to do this utilizing a factor tree. 4 times 10 is 40. 2 times 2 is 4. 2 times 5 is 10. Now, this time, I'm not going to list them in exponential form, just going to have the factors there. And then, to make sure that these don't run into each other, I'm going to change the color here. 60 is the same as 3 times 20. 20 is the same as 2 times 10. 10 is the same as 2 times 5. All right, so what I have is 2 times 2 times 2 times 5. And here I have 2 times 2 times 3 times 5. Now the greatest common factor only includes what is in common. The word common means a characteristic that is shared by two people. Like, oh, we both like to play volleyball. That is something we have in common. In numbers, it's numbers that are in both lists. So in this case, I have a 2 in my first list, and I have a 2 in this list. That is in common. That is a common factor. Now I have another 2 in the first list, and a second 2 in the second list. Whoops. That is another common factor. Then I see that I have a third 2 in this black list, but I don't have a third 2 in the purple list. That is not in common. Also, there's a 3 in this list, but not in the black list. Then I see that I have a 5 in common in both lists. I write down what's in common. then I actually multiply that out. And 2 times 2 is 4, 4 times 5 is 20. 20 is the greatest common factor. It is the biggest number that goes into both 4 and 60. Now, when we have variables, the process is very similar. You are going to see that I'm going to use a do the prime factorization of 6. 2 times 3. Then I'm going to list any exponents in expanded form. A times A times A times B. I'm going to do the same thing over here for 4A squared B. I need a little more space, so we're coming over here. 4 is the same as 2 times 2. Then A, B. Now I've got my red list and my blue list. Let's write what's in common between both of them. And when I list the common factors and multiply all of the common ones together, I get the greatest common factor. In the red list, I have a 2. In the blue list, I also have 1, 2. So they have a 2 in common. The other one is a 3. There's a 3, but there isn't a 3 in the blue list. So the 3 is not a common factor. There is a second 2 in the blue list, but I don't have a second 2 in the red list, so that one is not a common factor. Now with my variables, do you see that I have 2 A's in both lists? Well, those A's are common factors. There's a third A in the red list, but there isn't a third A in the blue list. So that third A is not a common factor. Both lists also have a B, and so that is a common factor. When I list the greatest common factor between 6A to the third B and 4A to the second B, I write it as 2A squared B. All right. Let's try this. Use the prime factorizations to find the greatest common factor in the two given numbers. Pause the video and come on back when you're ready to show me that you got it. All right, as you've noticed that the first couple problems don't have any variables in them. All right, so 2 times 2 times 2 is equivalent to 8, and 2 times 2 times 5 are the prime factors of 20. When I compare the two lists, I know that the greatest common factor is multiplying all of the prime factors that are in common. The green list has a 2, so does the black list. The green list has a second 2, so does the black list. So there are two 2's in common. This third 2 is not in common, and the 5 is also not in common. The greatest common factor is 2 times 2, which is 4. Make sure you actually multiply those out. Don't just say 2 times 2. Okay, the last one. We have 87 and 12. 12 can be broken down into 3 times 4 and 2 times 2. So I have 2 times 2 times 3. 87 is a little trickier, but 8 plus 7 is 15. So I know that it's divisible by 3, and I get 3 times 29. And then 29 is prime, so 3 times 29. The greatest common factor is, they do not share a 2, they don't share a second 2, they do share a 3, and they don't share 29. So my greatest common factor, is 3. All right. I think you guys are probably getting pretty good at this. Cross off this one in your notes. We're going to do this one. pause the video and try this one, the prime factorization of 3 numbers. This time, the greatest common factor has to be a common factor in all 3 of the factor trees. Pause the video and come on back. All right, hopefully you got the same prime factorizations that I got. Now the greatest common factor, we need to look at numbers that are all in every one of the numbers. 2, 2, and 2. Then there's a second 2 in common. There's a third 2 in common. There's a fourth 2 in common. So I've got 2 times 2 times 2 times 2. Here's where it ends. A 3 is in the green list, but not in the red or the blue list. A 5 is in the red list, but not in both the green and the blue list. The blue list has 3 additional 2s, but that isn't in common in the other ones. So my greatest common factor is 2 to the 4th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. My greatest common factor between all 3 numbers is 16. Okay. Then we're going to skip to doing some with variables. Oh, we're going to skip those. Here we go. I'm going to do the first one with you, just to refresh our memory. Just like with regular numbers and not without variables, we use a factor tree. 3 times 4, 2 times 2, and then again, list your variable. So 2 times 2 times 3, and then your exponents in expanded form. R times R times R. Now let's go to 8. 8 is the same as 2 times 4. 2 is prime. 4 is the same as 2 times 2. And then I only have one R. So 2 times 2 times 2 times R. All right, now I've got my 2 lists, the blue list and the red list. The greatest common factor lists whatever is in common. There's a 2 in common. There's another 2 in common. So let's write those down. 2 times 2. Now there's not a 3 in common because that's only in the blue list. There is a third 2 only in the red list, so that is not in common. There is one R in common, so we'll write that down. But the second and third R are not in common because they do not exist in both lists. Now let's summarize what we have. 2 times 2 times R is 4R. The greatest common factor is 4R. All right, it's time for you to give some of these a try on your own. See if you can complete the rest of them in your notes packet. There are 5. So this one, these 2, and these 2. Give it a try. Come on back and compare your answers to mine. All right. In doing the prime factorization, I can look and see in my list that they have a 3 in common, a 5 in common, and 1 m in common. So 3 times 5 times m is the same as 15m is the greatest common factor. All right. 2mn is already in prime factorization. 4 is the same as 2 times 2. So 2 times 2 times m, n, n. The greatest common factor here, they share a 2, they share 1 m, and they share 1 n. Okay. 75. 3 times 25. 3 is prime. 25 is 5 times 5. 5 is prime. 3 times 5 times 5 times, and then there are 3 x's when I write that in expanded form, and 2 y's. 100 is 4 times 25. 2 times 2 times 5 times 5. Let's write that in a different color. 2 times 2 times 5 times 5 times x times y. Okay, in common, I see there's not a 2 in common. I'm sorry, there's not a 3 in common. Yeah, there's not a 2 in common either, is there? But these 5s are in common. There are 2 5s in common. There's 1 x in common and 1 y in common. So I would write 5 times 5 times x times y, or 25xy. Good. All right, the last 2. All right, so in this one, the greatest common factor, I'm looking at my 2 lists. There's a 2 in each. There's a 3 in each. There is not a 5 and there's not an m. There's not a second 2, there's not a second 3, and there's not an n in any of them. So my greatest common factor is 6. No variable at all is in common. Okay? All right, 84. We're going to start over here. 4 times 21, 2 times 2 times 3 times 7. These are all prime. And then there's k, 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 n. I had to kind of squeeze that in there. 12 times 5, 4 times 3, 2 times 2, and I end up with 2 times 2 times 3 times 5, and then there's k, k, m. Last one, 6 times 6, 2 times 3, 2 times 3, that's prime. So you got 2 times 2 times 3 times 3, and then there's an h, and then 3 k's. Now let's find the greatest common factor between those lists. Well, I see that this list, and this list all have a 2. They all have a second 2 also. Then they all have a 3. They don't have a second 3, they don't have a 5, and they don't have a 7. So I'm done with the numbers. Now, this red list has an H, but none of the other lists do. The red list has a K and a second K. It looks like the blue list has 2 Ks, and so does the green. Now, the blue list has an M, but none of the others do, and the green list has more Ks and an N, and none of the other lists do. So my answer is 2 times 2 is 4, 4 times 3 is 12k to the second power.